Today in the workshop, we're working with EEPROMs. I'll show you how to use both internal and external EEPROMs to add non-volatile storage to your Arduino projects. We're making memories today, so welcome to the workshop. Hello and welcome to the workshop. Today we are going to be working with EEPROMs, electrically erasable read-only memories. Now this is a form of non-volatile memory. In other words, this memory will retain its data even when you remove the power from your circuit. Now non-volatile memory has a lot of use in designs. For example, if you were building a controller for, let's say, a CNC machine or a 3D printer, you probably have a calibration routine that you need to go through before you can first use it. And it would be very annoying to have to do that every time you started the project up. The calibration values could be held in EEPROM and they would be available every time that you powered the machine up. Another use might be something like a digital radio. If you were using an Arduino as a front end for a digital tuner, you would want to be able to store some of your favorite radio stations. And again, you certainly wouldn't want to have to reset that every time that you powered your project up. So again, non-volatile memory would be the answer to that. Now, we've worked with another form of non-volatile memory before, of course. We have used SD and micro SD cards, and they could be used for both of the applications I just described. However, it's a bit of an overkill. First of all, there's the cost. You would need to add a card reader onto your circuit, and while they're not expensive, it's a couple of dollars. And then the card itself, which is a few more dollars. Plus, it's a bit of an overkill for the two applications I just mentioned. Those applications just require you to hold a few bytes of memory, whereas the micro SD or SD card can hold gigabytes of memory, so it's a bit of a waste. Non-volatile memory like EEPROM is inexpensive, and as you're going to see, it's fairly easy to use. In fact, you may not even have to spend a dime to get non-volatile memory in your Arduino project, because the Arduino itself actually has some EEPROM built into it, and I will show you that in a few moments. So what we're going to do is we're going to start off, learn a bit about EEPROM and where it fits in with the family of different memory chips, and then we're going to start working with it with our Arduino projects. An EEPROM is an electrically erasable read-only memory. This is non-volatile memory. In other words, this memory retains data when the power is removed. Originally developed in 1973, EEPROMs were patented by NEC in 1975. These devices consist of 2 floating gate transistors per bit. Because they use 2 transistors per bit, the density of EEPROMs is not as great as technology such as RAM. They're available with a serial or a parallel data bus connection. Many microcontrollers, like the ATmega 328, have internal EEPROM. Let's see where EEPROMs fit into the memory family. A ROM is a read-only memory. Now, ROM chips are pre-programmed at the factory, and the user cannot alter their contents. An EEPROM is an erasable programmable read-only memory. EEPROMs are user-programmed and can be erased by using ultraviolet light. EEPROM chips have a small window on them to allow you to do that. These generally require a special EEPROM burner device. The EEPROM, or electrically erasable read-only memory, are user-programmed, and they can be erased with electric pulses. There's no special burner required, and they can be programmed right in circuit. Now, for all their advantages, EEPROMs also have a couple of disadvantages. The main disadvantage is that EEPROMs support a limited number of rewrites, although they can be read infinitely. 100,000 to 2 million rewrites are typical values for an EEPROM. Another thing with EEPROMs is they don't retain data forever. It's typically retained for at least 10 years at room temperature. So now let's start using EEPROMs. Now, as I mentioned at the beginning of the video, the Arduino does indeed have some built-in EEPROM, and the amount of EEPROM depends upon which model of Arduino you have. An Arduino Uno has 1 kilobit of EEPROM. Now, EEPROM is measured in bits, not bytes. So if you divide that by 8, you'll find out you've got 128 bytes of available EEPROM on an Arduino Uno. If you've got a Mega, you've got 4 times that. 4 kilobits or 512 bytes. And for many applications, this is going to be sufficient. Now, this memory should not be confused with the other memory within your Arduino. The Arduino also has some RAM, which is used just for operations, holding variables, etc. And it also has memory that stores both the bootloader and the program that you've uploaded to the device. The EEPROM is separate memory from that. Now, if this isn't enough EEPROM, you can also use an external EEPROM, and as you're going to see, they're very easy to use. The EEPROM I will be showing you is a I2C device. It connects very easily to the Arduino, and there are several third-party libraries you can use in order to interface with it. And we're going to be looking at both these types of EEPROM. Now, when you're using EEPROM, you have to remember there are some limitations, specifically limitations in the amount of times that you can write to it. As I mentioned in the presentation, you can read an infinite number of times from the EEPROM, but there are only a number of times you can write to it. And with the Arduino, that's about 100,000 operations. Now, 100,000 operations may seem like a lot, but it really isn't for some applications. If you were to write your EEPROM once every second, it would only take you a couple of weeks before you have completely exhausted the device and it cannot be used anymore. If you are going to be writing to it, however, occasionally 100,000 is certainly sufficient. So keep that in mind when you're designing your code. Only write to the EEPROM when it is absolutely necessary. So let's get started with the internal EEPROM in the Arduino. What we're going to need for this experiment is simply an Arduino Uno. I'm going to hook a couple of extra components up to it just so we can demonstrate the effectiveness of our EEPROM. So I'm going to move over to the workbench now. I'll show you how to hook this up, show you a simple sketch, and then we'll run the demonstration. Now here is what we're going to need in order to run our internal EEPROM experiments. We will need an Arduino Uno, and we'll need a potentiometer. Now I'm using a 10K linear pot, but you can use any value over 5K and it will work fine. We'll start by connecting one side of the potentiometer to the 5-volt output on the Arduino. The center or wiper of the pot will be connected to the analog A0 input on the Arduino. And finally, the other side of the pot will be connected to the Arduino's ground. And this completes the connections we need for our internal EEPROM experiments. Now, working with the internal EEPROM is quite simple because Arduino has kindly provided an EEPROM library, and this is included with your Arduino IDE. So you can go up to File and go into Examples, and you will see that the library has a number of different examples, 8 of them to be exact. We've got EEPROM Clear, CRC, Get, Iteration, Put, Read, Update, and Write. So basically, all of the different methods you would ever be required to use to work with an EEPROM are displayed in these examples. And so let's go and look at one of the examples right now. And I'm going to choose the Update one and maximize it. Now, you might think that write would be the first one that I would logically choose. After all, I want to write data to the EEPROM, but update is actually a better method. And the reason is, if you recall, the EEPROM has a limited number of write cycles. And so every time you write to the EEPROM, you're using up one of those write cycles. With the update method, a read is done first, and if the location contains the same data as it's about to be written, it excludes the writing. So it only writes data whenever there is a difference. It doesn't write it if it's the same thing. And this can reduce the number of times that you have to write to the EEPROM. Now the code itself is quite simple. First, of course, we include the EEPROM library. And then we take a look at the address of the EEPROM, like the address within the EEPROM. Remember, every space in the memory has an address. And we're going to start at 0. And there's nothing in the setup right now. The loop is also very simple. Now, as you recall, we have a potentiometer connected to pin 0 of the analog input. So we do an analog read, and we divide it by 4. And that's because the analog input will give you a value of 0 to 1024, and we need a value of 0 to 255. And so we divide everything by 4. Now, you could have used a map command as well for this, and it would perform essentially the same function. And then basically we just do an EEPROM update to that address and that value. We'll go down here and we'll add 1 to the address to increment it, and then we'll check the EEPROM length. Now the length is the size of the EEPROM, the number of bytes that it can store. Now remember, different Arduinos will have different lengths, and so instead of putting a fixed value, we use length. And as long as the address is below the length, we'll increment it by 1. If it equals the length, we'll set it back to 0. We'll delay over here, and that will basically be the end of the loop. We'll go back in over and over and do it again. So once we've gone through all the addresses, we'll go back to 0 and start doing it all over again. So very simple. We're going to write the value from the pot into the different EEPROM locations. So let's upload this to the Arduino and go and do that now. Now I'll have to admit this is not a particularly visually exciting demonstration, but what I'm going to do is upload the update sketch, which I've done right now. And here's my potentiometer on my Arduino, and I'm just going to turn the pot into a number of random locations. I'm going to sweep it end to end over here and give it a couple of extra values. And remember, every time I move the pot, the value is being read on the analog pin, and that value is being written into the internal EEPROM. So now that I've done that, let's go see how we can read that data. Now this is the EEPROM read sketch, which of course reads all the values in the internal EEPROM. It's a simple sketch as well. It starts off by including the EEPROM library, and then we set up an integer to represent the address within the EEPROM that we'll be using. We also define a byte that we call value, and that will represent the data value at that address. Now in the setup, we initialize our serial monitor, and then we go into our loop. And in the loop, we do an EEPROM read at the address that we've defined. And then we print the address, we print a tab character, and then we print the value in a decimal format, and we do a print lin in order to make a new line. After that, we increment the address by 1, and once again we look at the EEPROM length to make certain that we aren't exceeding the number of address locations in the EEPROM. If we are, we go back to 0, and then delay for half a second and do it again. So this should basically be printing out the values on our serial monitor of what we have in the EEPROM. So let's go take a look at the serial monitor right now. And it starts off, we have some values of 159. There we go, it's starting to move right now, and this is because I was moving the potentiometer. So here we go, it's decreasing down to 0, so we're at the very end. Now we're going up again. Now it's incrementing. And it gets all the way up to 255 at the other end, and goes down again. And this was, of course, because I was moving the potentiometer back and forth. So as you can see, it's also quite easy to read the values from the internal EEPROM. Now this is the EEPROM clear sketch. This is a sketch you can use to set all the values in the EEPROM to 0 and thus clear it so that you can use it again. And it's a very simple sketch. It includes the EEPROM library. There's no other variables defined, and when we go into the setup, we set up pin 13 as an output. Now as you'll recall, the Arduino Uno and many other Arduinos have an LED attached to pin 13, and we're going to be using that LED just to indicate that the job has been completed. And then we just basically go through an iteration, which is still in the setup, by the way, for the integer equals 1 to the EEPROM length, and we increment, we do an EEPROM write of that value and 0. So we'll go through all the address values up until the length limit of the EEPROM, and we'll write a 0. And then we will turn the LED high to indicate that we're done, and that's it. There is no code in the loop. So let's upload that to our Arduino. And it'll run right now. And that's pin 13 on my Arduino, so it is done. And so now what we can do is we can go back into the read sketch that we had before. And we'll upload that. And we'll go and take a look at our serial monitor now. And as you can see, now all of the values in our EEPROM are set to 0. So using these example sketches that come with the EEPROM library, you can do all of the basic functions that you would ever need to do with the EEPROM memory that's built into your Arduino. So now that we've seen how to use the internal EEPROM on the Arduino, let's take a look at an external one. Now the chip that I'm going to be using is an extremely popular one. It's called the AT24C256, and it has 256 kilobits of EEPROM, which translates to 32 kilobytes. This is an I2C device, and you can set the I2C address up yourself, and for that reason you can use multiple chips. So if 32 kilobytes of EEPROM isn't enough, you can add additional chips. Now you can get this chip by itself, but it's also commonly available on a number of breakout modules with the I2C connections and with either dip switches or jumpers in order to set the I2C address. And I'm going to be using one of the modules, but I'll also show you how you can use the chip individually if you'd prefer to do that. So let's go and take a look at this little module, and then I'll show you how to hook it up and how to program for it. The AT24LC256 is a 256 kilobit EEPROM. This is a serial EEPROM, and it uses the I2C interface to communicate, making interfacing very easy. It has 3 I2C address lines, which will allow up to 8 different devices on the same I2C bus. This device is rated as being good for over 1 million rewrites. Now here's the pinout of the 8-pin DIP package of the AT24L256. Pins 1 through 3 are the 3 I2C address lines. Pin 7 is the write protect line. In normal operation, this pin is grounded. However, if you bring it high, it will prevent writing to the EEPROM. Pins 5 and 6 are the I2C, SDA, and SCL connections. And pins 4 and 8 are the ground and positive 5-volt VCC. In addition to being available as an individual chip, the AT24LC256 is commonly available in breakout modules, making wiring and experimenting even easier. And we'll be using these modules in our experiments. Now here are a couple of modules that are based on the AT-LC256 EEPROM, and these are a bit easier to work with than by using the chip itself, but of course you can use the chip itself and everything will work fine. These simplify things though because they allow you to set the I2C address and connect very easily to the Arduino with a couple of jumper cables. And so on this module, for example, we've got some pinouts on the side. These are the pinouts for the I2C connection. This one actually has a tiny LED on it, so that'll just glow whenever the power is applied to it. And it's got some jumpers on this side, and the jumpers on it are being used in order to set the write protect and the 3 jumpers for the I2C address. Now on this module we have a similar arrangement. This doesn't have a built-in LED, but it's got the 4 pins again in order to connect the I2C. And on this one there's a very tiny little dip switch. And again it's got 4 positions, 1 for write protect and the other 3 to set the I2C address. So you may want to consider using these modules instead of the individual chip. They already have the pull-up resistors for the I2C, etc. But of course you can use the chip itself as well. For our external EEPROM experiment, we're going to need the following parts: an Arduino Uno, an AT24LC256 EEPROM module. You can also use the individual chip if you wish, but you'll have to make sure to wire it and include some pull-up resistors. A potentiometer. I used a 10K linear taper pot, but anything of 5K or above will suffice. A small servo motor. I used a standard SG90. And a power supply for the servo motor, which can be 5 to 6 volts. Now you can also power this from the Arduino supply if you wish. If you do, I would recommend adding an electrolytic capacitor across the supply lines to keep the motor noise from disturbing the Arduino. We'll start by connecting the module's SDA to the A4 pin on the Arduino. We'll connect the module's SCL to the A5 pin. The module's VCC will be connected to the 5 volts from the Arduino, and the ground will be connected to the Arduino's ground. Next, a potentiometer. We'll connect one side of this to the Arduino's 5 volt output. The wiper of the pot will be connected to the analog A0 input on the Arduino, and the other side of the pot will be connected to ground. The control line from the servo motor will be connected to pin 9 on the Arduino. The servo ground will be connected to the ground on the power supply, which also needs to be connected to the ground on the Arduino. Do not forget this connection. Finally, the servo power will be connected to the power supply for the servo motor. Now that we have this hooked up, let's take a look at the code we'll use for our experiment. Now here's the sketch that we're going to be using for our external EEPROM demonstration. Now first, before I show you this sketch, I should explain what it's going to do. As you recall, we have both a potentiometer and a servo motor hooked up to our Arduino. And of course, we're going to be using the pot to position the servo motor. We're going to record those positions into the EEPROM, and then we're going to play them back. And so we're going to start off our sketch by including the wire library, which is the I2C library. Now this is built into your Arduino IDE, as is this library, the servo library for the servo motor. Now note that we are not using a separate library for the external EEPROM, although there are several libraries we could use, including a popular one called ext EEPROM. We're just going to write functions to read and write the memory instead. Now the next thing we need to do is provide the I2C address of our module, and this is the I2C address in hexadecimal. You'll notice that's what the 0x at the front of it is, and this is the address you will get if you ground all 3 pins on the chip. The next thing we're going to do is define an integer which represents the potentiometer, the pin that it's on, and it's on analog pin A0. We are going to also have an integer that holds the potentiometer value. We're going to call that val and initialize that as 0. And another one to have the value we read back from the EEPROM. It's called readVal. It's also initialized as 0. Then we have an integer to hold the number of addresses we're going to fill. Now the EEPROM has over 32,000 addresses, but if we were to record all of this, it would take about 12 minutes to record and another 12 to play back. So in order to save time, I've just set the max address at 1500. Then we're going to create an object for the servo. We're calling that myServo. Now we go on to the functions that I've defined in order to write and read the EEPROM. The first one writes to the EEPROM. I call it write EEPROM, amazingly enough, and it takes parameters of the address within the EEPROM that we want to write to, the value we want to write, and the I2C address of the EEPROM itself. We start off by beginning the transmission to the EEPROM, so we do that with begin transmission to the address. And then we need to send the memory address within the device that we want to read. Now this needs to be set as 2 bytes, and we need to send them independently. So first we'll send the most significant byte over here, and then we send the least significant byte. After that, we're going to send the value that needs to be stored. So we're going to do a write of the value itself, and then we end the transmission. Then we add a 5 millisecond delay. This is required by the EEPROM between writes. The next function reads from the EEPROM. I've naturally called that read EEPROM, and the parameters it takes are the address within the EEPROM plus the EEPROM's I2C address. Now we define a byte for the received data, and then we begin the transmission again. Once again, we send the memory address as 2 bytes, and then we end the transmission. Now what that will do is it will cause the EEPROM to put the data at that location onto its buffer ready to be read. So we do a request to get a byte of data from the I2C address. So we request from the I2C address, and the 1 indicates that we want 1 byte of data. And then we'll read that byte of data, and then we will return that as the output of the function. Now the setup is where all the activity happens in this program, because we only want everything to happen once, so we're not going to do anything in the loop. We start off with a wire begin, and because we give it no parameter, that tells us that this is the I2C master. We're also going to set up our serial monitor so we can monitor the activity up over there, and we'll attach the servo motor to the myServo object on pin 9 of the Arduino. Then we're going to print to our serial monitor to indicate that we're starting the recording. And now we go into a for next loop to go through all 1500 addresses. So we go through the for next loop on each address, we read the pot value and use a map command to map it to a value of 0 to 180, which is what the servo motor needs. Then we write that out to the servo motor, and we delay 15 milliseconds. This allows the servo to settle into position, especially if it's going from one extreme to the other. Then we're going to record that position into the EEPROM, so we call the write EEPROM function we just defined, and we send it the address that we're sending, that's the memory address. We send it the value that we're sending, and we also know which I2C EEPROM address we're connecting to. And then we just print all of this to the serial monitor. So we'll print address equals or ADDR equals. We'll print the address. This is a tab character over here which formats it nicely. Then we'll do a println to print the value and do a carriage return. And then after we've gone through this 1500 times, we'll print to the serial monitor that we've finished recording, and we're going to insert a 5-second delay after that. And then we'll print again to the monitor to say that we're beginning playback. And once again, we go through a similar for loop over here from the address 0 to, in our case, max address, which is 1500. And we do a read this time. So we have read val assigned to the value of reading the EEPROM at that specific address. And then we write that value over to the servo, again delaying it for 15 milliseconds to allowing it to settle, and we print everything to the serial monitor. Finally, once that loop is finished, we go and we print playback finished, and then we exit the setup. Now there is nothing in the loop because everything in this program happens in the setup. So now that you've seen this, let's load it up to our Arduino and watch it work. Alright, I'm ready to run my experiment. Now here's my setup. It's a bit scattered, but I think you can see all the major parts. The Arduino, of course. Here's the EEPROM module, the potentiometer, and I've got my servo over here, and my connection to my power supply is back here. Again, make certain when you're using an external power supply that you tie the ground of that power supply to the ground of the Arduino, or it simply won't work. Now I'm going to reset this and start it, and we can take a look at the serial monitor. And as you can see, the monitor is displaying the positions, and I'm moving the pot around, and at one extreme it's at 0, and the other extreme 180, and then every value in between. So I'm just going to randomly move this around a bit. We can watch the servo move, and watch the serial monitor as we increment. Now remember, we're going to 1500 right now. Okay, we've hit 1500. It's finished recording. It's no longer responding to this. And now it's playing back after the delay. And as you can see, the serial monitor's reproducing the numbers, and the servo motor is reproducing the movements that we've used. So we've recorded all of that data now into the EEPROM, and that's what's playing it back. And we could rewrite the code if we wanted to, just to simply play it back from now on and repeat this motion every time the Arduino has started. Alright, so that wraps up our look at EEPROM for today. I hope that you've enjoyed it, that you've learned something, and that you're now inspired to use non-volatile memory in your next Arduino project. Now, if you need the sketches that I've used today, or you need a bit more information, you can check out the article that goes along with this video, and you will find a link to that below the video. And while you're on the DroneBot Workshop website, if you haven't subscribed to the newsletter, please do. I send you out the occasional email just to let you know what's going on in the workshop, and I promise I am not going to try to sell you anything. Now, if you want to discuss everything that we've done today, the best way to do that is to get onto the forum. You'll also find a link to the forum at forum.dronebotworkshop.com, and there are a lot of brilliant people who are on the forum every day having great discussions about all aspects of Arduinos, robotics, automation, and pretty well everything that you can think of. So it's a great gang, and if you're not a member of the forum yet, please join up and participate in the discussion. And finally, of course, if you have not subscribed to the YouTube channel, I would be very thrilled if you would. I always appreciate getting new subscribers, and it's the nicest way to say thank you for the videos. So if you haven't subscribed yet, just hit the subscribe button below the video, or click on that little robot in the bottom corner and he'll do the job for you. So until we meet again, take care of yourselves, have fun working with your EEPROMs, and I hope to see you again very soon here in the DroneBot Workshop. Goodbye for now.